and welcome to Nkumat Online Academy. Yeah, welcome back to our discussion on laws of motion. In our last lesson, we talked about the introduction to motion, first law of motion, second law of motion, and we also talked about moment. Then today we want to look at the third law of motion and then impulse, principle of conservation of momentum, inelastic collision, and applications of the laws of motion. Now, the third law of motion. The third law of motion states that the action produced in a body or the action applied to a body is equal and opposite in direction to the reaction on the body or the reaction produced. That means that the action and reaction are equal but opposite. The action and reaction are equal but opposite. What this is actually saying is this: when we have a body and we apply a force to it, the force we are applying is the action force. There will be a force coming back, it will produce an effect. The effect of the force we apply to the body is what we call the reaction. And the law is telling us that the force applied is equal to the effects produced but in opposite direction. We have an analogy for this. When you beat someone, maybe you'll be happy to beat someone, you will see that the effect it will bring on a person is sadness. You are happy, you're enjoying it, beating someone, but the person is not enjoying it. The person will be very sad for the beating you are giving the person. So the happiness in you is producing bad effects on someone. That is the opposite effect. Now, the more you beat the person, the sadder the person will become. So it means that the force is equal to the effects. That is, the action is equal to the reaction. I'm just bringing this as an analogy for you to understand the concepts of the third law of motion. So the formal definition of the third law of motion is that the action and reaction they are equal but opposite. Action and reaction are equal but opposite. Now, we know that the effect on a body is what we call impulse. The effect on a body is what we call impulse, and we can get this impulse from momentum. We gave the definition of momentum when we talked about the second law of motion, and in that second law of motion we said that F we started by saying that force is equal to mv minus mu over t. That is the formal definition of second law of motion, which gave us F is equal to ma as the statement or the mathematical expression for the second law of motion. Now we started with this. Now, if we transform this equation, we are going to get something like if we use this, if we bring the t to this side, that means multiplying f by t. Then we are going to have that ft is equal to mv minus mu. This is called impulse. This ft is called impulse. So if you are asked to calculate or to find the effect, the impulse on a body, it means that you should find the ft. If you are given force and you are given time, you multiply two of them and you get impulse. Impulse is actually defined as the product of force and time. The product of force and time. So you can either use the force and time to get it if you have them, or they can give you these parameters m, v, and u. Then you multiply each of them and subtract to get the impulse. Now look at what you can do with this. In third law of motion, we say that the applied force is equal but opposite to the effect. Now that means that the applied force is equal to momentum. Now we have a law we call the principle of conservation of momentum. In the principle of conservation of momentum, it is saying that the momentum of a body is conserved. That the momentum of a body. Now what is meant by the fact that momentum is conserved is that if you have like two bodies traveling and they collide with each other, that the momentum before collision is equal to the momentum after collision. Now let's say that the momentum before collision is, let's say that you have two bodies, or a body m1 and m2 of, let's take one of the bodies. Now let's have two bodies m1 and m2. That is, let's assume that these are two different cars with their masses m1 and m2. Then let's say that they initially have velocity of u1 and u2 and they collide. After the collision, their mass will remain the same. Mass does not change, so they'll still have m1 and m2. But two things can happen. It is either that two of them collide and they stick together and start moving with the same speed. That is the same velocity. So this velocity will become, that's the final velocity now. Let's call it v2. Now the law of conservation, okay, another thing that can happen is that it is either two of them stick together and be moving with this velocity, or each of them move with different velocity. That is when they don't stick together. I'll be talking about two of them separately. So we can have v1 and v2. Now let's assume that two of them start moving at the same speed. Now what will happen then is this. Since we say that the momentum is conserved, it means that momentum is m for the first mass m1 u1. Their momentum before collision, these are two bodies moving. The first one has this momentum and the second one has this momentum m2, then u2. Then, after the collision, if two of them stick together and are moving at the same speed, now we are going to have V. Let's say we have M1. The mass does not change. M1 V2. Velocity is the same for two of them because two of them are moving with the same velocity. Then M2 V2. Now, since the velocity here are the same, then we can factor out the velocity and say V2 bracket M1 plus M1 plus M2. This is called inelastic collision. This is the formula for inelastic collision. That is when two bodies collide and they are moving with the same speed. The formula is M1 U1 plus M2 U2. This is U. M2 U2 is equal to V2 bracket M1 plus M2. Now, the next thing that can happen is when two of them collide and they start moving at different speed. That is when they collide and they don't stick together. This one will be moving to this side, and that one will be moving to another side at different speed. Now, if they have different speeds, this is what will happen. Then we have that our M1 U1 plus M2 U2, this is going to give us M1 V1. That means we have different final velocities. Then we have V1 and V2. So M1 V1 plus M2 V2. Now, what this means is that, so we are not, there's no common factor between two of them. So we leave this, and this becomes the formula for elastic collision. Formula for elastic collision. So these two formulas are very, very important. This is the formula for inelastic collision, and this one is the formula for elastic collision. Now let's use them and solve some examples. Let us assume that we have this body. We have a body of mass m equal to 2 kilogram, and it collides with another. It is moving with a velocity, initial velocity of 4. A body of mass 2 kilogram moving with a velocity of 4 meters per second collides with another body of mass 3 kilogram moving with initial velocity of 5 meters per second. Now, if after the collision, the two bodies start moving in the same, if after the collision, the two bodies stick together and start moving at the same speed, calculate the final velocity. If after the collision, the two bodies stick together and start moving with the same velocity, calculate the final velocity. Now, this is a case of what? Inelastic collision. This is a case of inelastic collision in which the two bodies stick together and they'll be moving at the same velocity. And the formula for it is now here we are looking for V2, which is the final velocity. We know our M1, M2, and we know our U1 and U2. Now we put everything in the formula and we get what we want. M1 is 2. M2 is 3 and U is 5. So this is equal to the final velocity, which is what we are looking for, V2 2 times 4 is 8. 3 times 5 is 15. 2 plus 3 is 5. So we have that's 23 is equal to V2, 5V2. Then V2 is equal to 23 over 5. So whatever we get from this is the answer. That is the velocity, the final velocity when these two bodies collide and start moving, stick together and start moving with the same velocity. So this is how to calculate inelastic collision. Now let's see another example. Now let's assume that we have a body. This same body Now we have the same two bodies, mass or two cars of mass 2 kilogram moving with an initial velocity of 4 meters per second collide with another body or another car of mass 3 kilogram moving at an initial velocity of 5 meters per second. If after the collision, the first car start moving with a velocity of 1 meter per second, find the velocity of the second car if the two cars do not stick together after collision. Now, if there is no stickness, or if they don't stick together after collision, then it becomes a case of elastic collision. And in elastic collision, we use the formula here. M1U1 plus M2U2 is equal to M1V1 plus M2V2. Okay, so here we already know our M1U1, M2U2, M1V1. What we are looking for is V2. No, this is 4. Yeah, U1 is 4. Okay, so we move 2 to the other side. Eight plus 15 is 23. Twenty-three minus 2 is equal to 21. Then V2 is equal to 21 over 3. So whatever you get, this is the velocity for the second car. So this is how to calculate elastic collision. So in this lesson, we have looked at the meaning of the third law of motion. We've looked at the principle of conservation of momentum. We've also looked at the meaning of impulse, and we've looked at elastic collision and inelastic collision and how to calculate or use the elastic and inelastic collision to find velocity or any other parameter we are looking for when two bodies collide.